Hello, let's continue our Sudoku adventure with Temperature Swings by Riffclown. So this is puzzle number 1101, and per tradition, every 1 and 51 is set by Riffclown. So here we are, and they tend to very commonly be irregulars with thermos. So let's go over this one. So we have irregular 6x6 Sudoku rules. That means in each row, each column, and each bold outlined region, we are placing the digits 1 to 6 exactly once each. So we don't have our normal 2x3 boxes. Instead, it's more like a jigsaw puzzle, but there are still 6 regions with 6 cells each. And we put 1 to 6 once each in them. We also have these thermometers in the grid. They have a bulb end and then a stick coming out, a line coming out. We just have to strictly increase from the bulb. So as we move along the thermo, we have to just get bigger and bigger and bigger. Stay the same, can't get smaller. So if this was, say, a 2, this could increase to, say, 4, 5, 6. That would be one way to do it. But you don't have to, you don't have to be incremental. You could go 1, 2, 5, 6, or 1, 2, 4, 6, or 1, 2, 4, 5. Just as long as you keep getting bigger. What we can't do is 1, 1, or 2, 1, right? We can do 2, 4. We can't go back down to 3. You have to keep getting bigger. Hopefully that's clear. That's it for the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right. So often with Riffclown irregulars, you want to look for geometry. So this 3 that we're given, where does it, we know that this region has 1 to 6 once each. So it's going to have a 3, but where does the 3 go? Because we can't repeat in the column and we can't repeat in the row. So this region here must have a 3 and it must be there. Now, sometimes you can keep going. Let's see. This region needs a 3. Okay. I'm not sure if we can keep going. I'm looking. Let's see. I know that I need a 3 in this column, and it doesn't go here because of that 3. So the 3 is in one of these two, at the very least. All right, I want to think about the thermos now then. So I'm not sure if we can color this puzzle or not. We know that these 2 go down here, right? Because this column has 1 to 6. This region has 1 to 6. These are shared. So these 2 have to go down here. It's called the law of leftovers. 3's in one of these. Let's see. This can't be a 3 though. No, it can be. Sorry, I misjudged. 3 is possible here. It's the highest it could be. It would force 4, 5, 6 along it, but that seems okay. I wonder. So most of these are 4 length. This guy is 3 length. This guy's 2 length. I guess 3 of these are 4 length. So I guess that counts as most. So in the I'm gonna pencil these. So in the bulb, I'll pick this one. Here's how I would pencil if I didn't already know there were 2 degrees of freedom, right? So I guess one way to think about it is it's 4 length. 6 length would be the max. So we have 2 degrees of freedom, which means that we can be 2 higher than our minimum. So we could go 1, 2, 3, right? The minimum is 1. We can go 2 higher than it. We can go to 2 to 3. And that represents our 2 degrees of freedom. The other option is just start here. 1, 2, 3, 4. Ignore other Sudoku rules in order to get this penciled. And then from the end, we know the end can go up to 6. And so then we can fill that gap, 4, 5, 6. So, but we can go 6, 5, 4, 4, 3. And then we'd fill the gap in between 2, 3, 4, 5. That's another way to pencil it if you don't want to think about the math. Either way, you end up with this penciling. But this can't be a 3. And since that can't be a 3, we remove the smallest. That propagates up. The way, you can see that this can't be a 4 anymore because 4 is not bigger than 4 or 5, right? 4, it would be equal. 5 would be larger. So in order to keep getting bigger, we need to be at least 5. All right. So we can pencil the rest of these. These are 1, 2, 3, and I'll clean it up after. This is 2, 3, 4. This is 3, 4, 5, and this is 4, 5, 6. Okay, so now we clean up. We remove the 3 here. That would propagate lower. That would propagate the other way, but there's nothing the other way, so it's fine. Moving the middle value does not propagate at all, but removing this 3 does remove this 4. And then this can't be 3, but that doesn't propagate anywhere, right? So oftentimes the questions we can ask are where do 1 go or where do 6 go? And now I'm seeing that in this box here, we do need a 1. And 1s can only go in bulbs or not on a thermos. If it's a thermocell, 1 can only go in bulb. Like if I try to put a 1 here, how would I make this smaller than it, right? So this is the only place, everything is a bulb, or sorry, everything's a thermocell in this region, and this is the only bulb. So this has to be the 1. We know we need a 2 down here somewhere. All right, so let's think about 2 then, or 6. 6 is actually a good one to think of, because 6 can only go on tips. None of these are tips. So this is our 6. That makes that 5, which propagates down to 4, which actually gives us the 2 and the 1. Very nice. That's 3, that's 4. And that gives us the 3. That's 4, so that has to be 5 or 6. All right, this isn't a 3 anymore. We have a lot of 3s now. This region needs a 3, and these 3 3s say not here, and this is, the thermo says not there, so this is a 3. That forces this to be at least 4, but it can't be 4, and it can't be 6, so that's 5. So our 3s are done. I bet you we can just finish this with Sudoku. I need a 1 2 here. These are 1 2 6, so I know that's not 6 because of the thermo. That's a 1 2 pair in this region and row. So we need 4 5 6 here. That's not the 4, so that's our 4. And then for this row, this is the other 5 6, right? These two are the same. I need a 4 5 here. This 4 looks down, so that's 5, that's 4. That gives us the 6 here, and the 6 in this column. That gives us 5 6 5. This is, let's see, these aren't 1 because of that 1. So the 1 in the row goes here. And then we're left with a 2 6. This 2 says that's 6, that's 2. This column finishes with a 6. This column needs a 1 4. The 1 2 pair says not here, so that's 4. That's 1, or the 4 said it as well. I should say resolves it. This row needs a 2. This box needs a 5, or the column, whatever. Let's see here. This needs to be a 2, and that gives us the 1 and the 2 here, and the 2 and the 1 there, and we're done. As usual, nice irregular logic from Riffclown. It seemed like the key was noticing that this region was fully thermoed, and so 1 and 6 had to get placed. That seemed to do quite a bit. Penciling these also helped quite a bit. I don't think it was necessary to pencil this thermo or this thermo. All right, cool. Well, let me know how you did, and if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.